All right, here we have an exercise called monotonic array. We want to check if an array is monotonic. So an array is monotone increasing or monotonic increasing if each subsequent element is always greater than or equal to the previous one, and monotone decreasing or monotonically decreasing if every subsequent value is less than or equal to the previous value. So what we want to do is we want to determine if an array is monotonic or not. And this, so this is sort of like just writing it out here. This is like an easy condition to check. But what makes this tricky is the fact that two elements being equal doesn't automatically categorize it as increasing or decreasing. So we want to do this in a way where like you can have a sequence that has like a bunch of like strictly greater than elements and then a bunch of equal elements, and this will still look like in a potentially increasing monotonic increasing array. And so basically the way that we can think about this is that like what condition do you need to have for an array to not be monotonic, either increasing or decreasing? Well, we can ignore the equals because at any time two adjacent elements or two adjacent values are equal to each other, that doesn't give us any information about monotonicity. What really matters is when we have like gaps which are strictly positive or strictly negative, trying to figure out if you ever have a case where you have one gap that's strictly positive and another gap that's strictly negative, because you can't have both of those things at the same time. And so you can think about a few ways to do this, but one way that you can do this is sort of like have, one way that I first implemented was to sort of like have like a flag or have like a variable to store whether or not the direction has been determined, and then have an additional variable to store what the direction is. And so then basically if direction determined, and basically the direction gets determined as soon as you observe a non-zero gap between adjacent values. And then so you just keep going until the direction is determined, and once the direction is determined, if it is the case that once the direction is determined, then you can set the direction to be positive or negative, increasing or decreasing based on whether that gap in values was positive or negative. And then from there on out, you just check to see if you ever get a later gap which conflicts with that original direction that you determined. So that's one way of doing it, but there's another way of doing this that uses a little bit less code. And basically, instead of having one variable to keep track of whether the direction has been determined and another variable to keep track of what that direction is, you can have two variables which indicate whether the array is potentially increasing and whether the array is potentially decreasing. And so that's what we're going to do here. I'm going to write this out because I like writing. So we're going to set increasing equals to true and decreasing equals to true. So these two variables, increasing is storing whether this array is potentially increasing, and decreasing is storing whether the array is potentially decreasing. And basically, we want to go through, and anytime we see a non-zero gap, then that rules out one of these scenarios. And so we set that to false. And then we continuously check if we ever run into a situation where both of these scenarios have been ruled out. And anytime we run into such a scenario, we know that we are no longer dealing with a monotonic array. Okay, so let's loop through the array, and we want to get all the gaps. So we're going to loop for I in range, and so we want to be comparing adjacent values in the array. I is going to be the higher index, and I minus 1 will be the lower index. So we want to start at 1, because the first pair of indices we want to look at is 0 and 1. And where do we want this to end? We want, at the very end, the very last pair we want to compare are the two final indices in the array nums. And nums, so if I'll just use n to refer to the length of nums. So then, because indices start at 0, the final index in nums is going to be n minus 1, and the second to last index will be n minus 2. So we want the last value of I here to be n minus 1. And so we're going to set it equal to length of nums here, which is n, as I've been describing out loud. Because remember, with range, you go up to but not including the number at the end. So this will have integers up to but not including the length of nums. And that's exactly what we want, because we want to end at length of nums minus 1. Okay, so basically now we check if either increasing or decreasing has been ruled out. So if that is not how you spell nums, that is not how you write well. If nums we look at the gap. If this gap is positive, if this gap is positive, but another way that we can write that is just more simply, if the ith value is strictly greater than the I minus 1 value, then that is a strict increase. And so if that ever happens, then we know that the array cannot be decreasing. And so then we will set decreasing equal to false. And then conversely, if nums, I don't know am I using conversely in the mathematically correct way? I'll say, on the other hand, if nums I is strictly less than nums I minus 1, then this is a strict decrease, and so this sequence cannot be increasing. So increasing equals false. And now we check at every stage, we check if we've ever run into a scenario where we've ruled out both an increasing and a decreasing sequence. So if not increasing and not decreasing. I guess you could also write if not and then in parentheses increasing or decreasing. But what is that, modus ponens or something? I don't know. This is fine. This is more readable. This makes more sense. Let's just keep it like this. Keep it simple. Okay, so if we run into a scenario where this array is not increasing and is for sure not increasing and for sure not decreasing, then this for sure is not a monotonic sequence. And so we return false. And then we go through this loop, and if we get to the very end of this loop and we haven't ruled out both increasing and decreasing as possibilities, then it has to be a monotonic sequence. So at the end, we will return true. And by the way, so just as a disclaimer here against just blindly using LLMs for exercises like this. So when I was preparing this video, I asked GPT-4 to solve this exercise. And what it did was at the end here, it said return increasing or decreasing, because at the end we want to return true if either the sequence is potentially increasing or if the sequence is potentially decreasing, or both, which would be the case if it was entirely a zero sequence. But if once we get to the end of this loop, it's not possible. Like once we get to the end of this loop, the statement increasing or decreasing will always evaluate to true, because the only way for it to not evaluate to true would be if at some point both increasing and decreasing would evaluate to false, in which case it would have been caught at this line of code and it would have returned false. Now I think what you could have done instead is like just completely remove this test here at each step, and then at the very end return increasing or decreasing. And that would be valid as well. And it would take like one fewer line of code, but it's good to include this sort of early stopping condition here, because this way, like if you have a super long array and like the first gap is strictly positive and the second gap is strictly negative, you can just exit the loop immediately and immediately return false without having to loop through the entire array. But yeah, so it's always good to, obviously, like it's fine to use LLMs to help figure out solutions and help think through code. But it's always good to look through what it comes up with. And plus, that's also like, the point of this is to learn, and so that it's a learning tool. It will help you learn, and having to audit it will help you learn. Okay, so let's type this out. So in potentially increasing sequence, or potentially increasing array and potentially decreasing array, we'll set these to true. And then we'll loop from 1 up to the length of nums. If we run into a scenario where the nums I is strictly greater than the previous value, then the sequence can no longer possibly be decreasing. So we set decreasing to false. If on the other hand, if nums I is strictly less than the value that came in the previous index, then that's a strict decrease, and so increasing can no longer be true. So we set increasing to false. And then at the end of each step, we check if we have ruled out both the possibility of an increasing and a decreasing sequence. And if we have ruled out both possibilities, then this cannot be a monotonic sequence, so we return false. If we get to the end of the sequence, or if we get to the end of the loop, and we have never ruled out both increasing and decreasing as possibilities, then one of the two is, or possibly both if it's just an array consisting of a single value repeated. Anyways, it will evaluate to true. It will automatically be monotonic. Okay, so here's our code, and let's run it. And there we go. So that is how you solve this problem.